For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@databasehomeworkhelp.com or reach us at https://www.databasehomeworkhelp.com. Problem 1. To reduce the number of plans the query optimizer must consider, the Selenium optimizer employs a number of heuristics to reduce the search space. List 3. Solution. A. Push selections down to the leaves. B. Push projections down. Consider only left deep plans. C. Join tables without join predicates, cross-product joins, as late as possible. Problem 2. Give one reason why the redo passive arrays must use physical logging. Solution. The pages on disk may be in any state between no updates applied and all updates applied. Logical redo cannot be used on an indeterminate state, whereas physically redo. Databasehomeworkhelp.com. Logging just overwrites the data on disk with the logged values. In other words, physical logging is idempotent whereas logical logging is not. 2. Optimistic concurrency control. Problem 3. For the following transaction schedules, indicate which transactions would commit and which would abort when run using the parallel validation scheme described in the Kung and Robinson paper on optimistic concurrency control. Also give a brief justification for your answer. You may assume that if a transaction aborts, it does not execute its write phase, rolling back instantly at the end of the validation phase. Databasehomeworkhelp.com. Solution. Transactions that commit, T1, T2, or T1 transactions that abort, or T2. Justification. There are two correct solutions, T1 and T2 both commit. T1 commits because it validates first. T2 will also commit because while its write set intersects T1's write set, T1 finishes its write phase before T2 starts its write phase, condition 2 in section 3.1 of the paper. T1 commits, T2 aborts. T1 commits because it validates first. In the pseudocode from the paper, section 5, T1 is executing the line-marked write phase when T2 starts its validation phase. T2 finds T1 in the finish active set, and aborts due to a write/write conflict. This is sort of a false conflict, since it would be safe for T2 to commit. However, the parallel algorithm assumes that T1 is still writing at the time that T2 detects the conflict, so it must abort. Problem 4. Databasehomeworkhelp.com. Solution. Transactions that commit, T1, T3 transactions that abort, T2. Justification. T1 and T3 commit, T2 aborts. T1 commits because it validates first. T2 must abort because T1's write set intersects T2's read set, and T2 was started reading before T1 finished writing. T3 then commit because although it has a conflict with T2, when it begins the validation algorithm, T2 has already aborted, it finishes aborting at the end of the validation phase. Databasehomeworkhelp.com. 3. Schema design. Consider a relational table. Professor name, professor ID, student name, student office ID, student designated refrigerator ID, refrigerator owner ID, refrigerator ID, refrigerator size, secretary name, secretary ID, secretary office. Suppose the data has the following properties. A. Professors and secretaries have individual offices, students share offices. B. Students can work for multiple professors. C. Refrigerators are owned by one professor. D. Professors can own multiple refrigerators. E. Students can only use one refrigerator. F. the refrigerator the student uses must be owned by one of the professors they work for. G. Secretaries can work for multiple professors. H. Professors only have a single secretary. DatabaseHomeworkHelp.com. Problem 5. Put this table into third normal form by writing out the decomposed tables. Designate keys in your tables by underlining them. Designate foreign keys by drawing an arrow from a foreign key to the primary key it refers to. Note that some of the properties listed above may not be enforced, i.e., guaranteed to be true, by a 3NF decomposition. Solution. DatabaseHomeworkHelp.com. Problem 6. Which of the 8 properties H of the data are enforced, i.e., guaranteed to be true, by the 3NF decomposition and primary and foreign keys you gave above? Solution. B, C, D, E, G, H. The schema does not enforce that prof/secretaries have individual offices or that students use the fridge of the professor they work for. Problem 7. What could a database administrator do to make sure the properties not explicitly enforced by your schema are enforced by the database? Solution. Use triggers or stored procedures to ensure that these constraints are checked when data is inserted or updated. DatabaseHomeworkHelp.com. For external aggregation. Suppose you are implementing an aggregation operator for a database system, and you need to support aggregation over very large data sets with more groups than can fit into memory. Your friend Johnny Join begins writing out how he would implement the algorithm. Unfortunately, he stayed up all night working on Lab 3, and South trails off in an incoherent stream of obscenities and drool before finishing his code. His algorithm begins as follows. Input, table T, aggregation function F name, aggregation field ag F, group by field GBYF / assume T has T pages in your system has M pages of memory / partition phase in T / M, allocate BUFS, N pages of memory for output buffers, allocate F files, an array of N files for partitions, for each record are T do H hash, r.gbyf. /*h, 1 yen, * write r into page BUFS h. If page BUFS h is full, then add BUFS h to file F files h and set the contents of BU FS h to empty. End. DatabaseHomeworkHelp.com. N / aggregate phase for each FF files do / your code goes here. End. Problem 8. Relative to T, how big must M be for the algorithm to function correctly? Justify your answer with a sentence or brief analytical argument. Solution. Because BUFS should fit in memory, N less than or equal to M. T, the number of hash buckets, is computed as N equals M. T plugging in for N, we get that M less than or equal to M. Therefore, T less than or equal to M2. It follows that M greater than or equal to square root T. Problem 9. Assuming the aggregate phase does only one pass over the data, and that F name equals AVG. DatabaseHomeworkHelp.com. Describe briefly what should go in the body of the for loop, in place of your code goes here. You may write pseudocode or a few short sentences. Suppose the system provides a function emit group val to output the value of a group. Solution. All tuples with the same GBYF will end up in the same partition, but there may, very likely will, be multiple GBYF values per partition. The basic algorithm should be something like H equals new hash table / stores, GBYF, pairs for tuple T and F, if equals H.get T.gbyf, equals null, sum equals sum plus T.ag CNT equals CNT plus 1 T.put T.gbyf, for, group, in T, emit, group, sum /CNT.